Hello folks, and welcome back to the MOSHIXX mainframe channel. This is MOSHIXX, and today we'll do part 2 of the exploration of the IBM high-level assembler. Given that I have been granted generously access to one of the viewers' ZOS systems, and I don't know how much longer I will have access to that system, so I thought I'll follow up quickly with a more in-depth look at the IBM high-level assembler, because that's I think one of the biggest benefits of working with ZOS from a programmer point of view, especially from an assembler point of view, is of course the high-level assembler. The FX assembler we have in MVS 3.8 as delivered with the TK4 distribution is very good. I like that assembler a lot, and especially given that a group of people in the TK4 developer community led by Jürgen Winkelmann and a lady called Shelby and some other people have actually added S390 instructions to the S370 architecture, so and then made the FX assembler being able to recognize those instructions and use them. So actually, you could actually write S390 code on the FX assembler and get it to run then on an S390 architecture. I'm not quite sure if you can directly port an object module, but I think it should be possible. So the FX assembler in TK4 will produce, will assemble even instructions that are much newer than the instructions that existed when the FX assembler was originally created in the 70s. So it's a very good assembler, but obviously it's an assembler from the 70s, and IBM, when they created the high-level assembler, I think early 90s, put a lot of thought into it. And the gentleman who led the development effort, John Erisman, had just recently retired from IBM in San Jose, California. But the product is just amazing. And John Erisman also published a book in PDF form about mainframe assembler programming in general and the high-level assembler in particular, which is very good. It's a very thick book, but I have printed it out and I have been reading it for the last couple of weeks in anticipation of making these videos. So, but let's go and look a little bit at the difference between FX and high-level assembler before I show you some neat few things that you can do with the high-level assembler. So, as you all know, Professor Dijkstra back in the 60s said something that is actually very smart, and that is, he said, for a number of years I've been familiar with the observation that the quality of a programmer's work is a decreasing function of the density of go-to statements in the programs they produce. More recently I discovered why the use of the go-to statement has such disastrous effects, and I became convinced that the go-to statement should be abolished from all high-level programming languages. And from there, the famous sentence, the go-to statement considered harmful. And so Professor Dijkstra, who was not an easy person to deal with, I was told by people who worked with him, but he was very much against the go-to statement. And in fact, you know, there is then this kind of statistics, which is the go-to use in languages. In Fortran, the go-to is required. We don't really need this line here. In Fortran, the go-to is required. You cannot program in Fortran without the go-to statement. BASIC also needs the go-to statement. If you've seen my video on the usage on the installation of BASIC on MVS 3.8, you will see why the go-to statement creates such ugly code with that interesting BASIC compiler. C, you very rarely need the go-to statement, but sometimes you do need it. In the Linux kernel, I think there's about 100 go-to statements the last time I counted. Rex Sometimes, very rarely, it is used in ADA. I've never seen it in C++. It is there, but I've never seen it. Perl, I have actually had to use a couple of times. I still like Perl quite a lot. I don't know why Perl has such a bad reputation. It's really a neat language. It's very fast. You know, you can create things very quickly in Perl. I still use it. Visual Basic, you shouldn't need to use the go-to statement. Python and Java have no go-to statement. And then here is another part which says that go-to usage is directly related to software quality. And so why is that? Because out-of-line logic paths make program harder to follow. Everybody knows that. You have to follow the go-to statement, and it's just an additional exercise for the reader to understand the code. Every branch is an opportunity to create out-of-line logic, and therefore structured programs avoid this pitfall. It's quite logic. So I'm saying this because in assembler, you almost by definition using go-to or branches, right? And there's really no way to avoid it. In fact, a lot of circuitry on the processors is dedicated to predicting the branches, because in assembler go-tos or branches are really non-avoidable. But you can still program so that so that you avoid these pitfalls. And so the high-level assembler has actually created macros which allow you to write code using macros that is structured, and then the assembler will still, of course, turn it into branches. Here is an example of high-level assembler and what you can do with that. So here is a simple assembler that just shows here is, so far everything is good. We just established addressability with register 12. Then we save the registers that we got in on entry into the save area, which is defined here as 18 full words. And then here you have the usage of a do here and end do, which are just macros. It's not instructions. It's not machine instructions, obviously. There is no such thing in the mainframe architecture, obviously, or no other architecture. And then you have if and else and end if. So now look at this, how much easier it is to read than code, for instance. If you compare this, let's say something like this. So this is very simple, but here you have a loop, right? You get a record, you load the address of the record, print it on the printer, clear the output area, insert a new print line, and go back. And then compare it to this, where you just have a do and end do. So this is a loop, looks much cleaner. Also in high-level assembler, you don't need to use caps only. And you can also have empty. I can also delete this comment here, and that would still be valid. You can have just empty lines, which of course in the FX assembler on the MSGCLASS 3.8 operating system, you can't do. You need to have a comment line in column 1 for the line to stay mostly empty, or you can do an eject to so that in the printer version it will look cleaner. But so anyway, so you can mix caps and lower caps, and then you can have structured programming like this. There's a bunch of structured programming macros. You can have do while, you can have do and do, if else, and some other neat tricks. It makes programming in assembly here very, very similar to actually to a high-level language, which I wanted to play with a little bit more, and so I really like this part. I think, since I'm not really doing a tutorial on high-level or on mainframe assembly programming here, I think this is all that we need to show here, and we've done enough exploration on high-level assembler. when it comes to the language features. And then some of the readers have contacted me either by email or also in the comments in the previous video in part 1, and they asked if I had done some stuff on Unix System Services on z/OS 13 or whatever it's called, and I said no. And then Bob, who's giving me access to this machine here, said I could have access to the Unix on z/OS, and I said, well, that would be neat. And Bob also said that, you know, he needs me out of the machine in the next few days, so I will not have access to this mainframe much longer. But as long as I can, he has generously granted me access to this. So I have an SSH into this machine, and so I logged in. And once you log in, it's actually surprisingly trivial. It's just like any other Unix. You can see here from this that we are on a mainframe. I don't know why it says OS 390. I don't really know. 23. I don't know what this all means. This is probably the machine type. I don't know. I think this is an IBM mainframe type. And then you know, we just have stuff like this. I think you mentioned that there is a bash even installed here, and you mentioned in the email that it's under no, it's not. No, I don't know what I was referring to. So once you log in, you're in a subdirectory called U, and so I'm in U MOSHIXX, obviously. Yeah, so I wanted to try. There's an assembler installed, and I guess it's the exact same assembler. I don't know if it's the same binary that it's loading when you execute it, but I wanted to try this, and in particular, I wanted to try a tiny little program here, which is this one. Oh, memory is in use. Yeah. Yeah, this one. I wanted to try to get this program to compile here in the Unix command line. That would be neat, wouldn't it? So let's call it YouTube. So we have the VI editor installed, which is all I'm asking for. And then I copy these lines. And then this remaining lines. And that's, I think, all we really need. Yeah, this doesn't look so good. Okay, now this looks good. And let's see, I've never done this before. This, I don't really know so how this works. Assembler minus E G M R S X. Oh, I need to give it the. There is no auto completion here, so EGMRSXU2.AS. AS. Let's make it. Oh, okay, I understand. Return code 0. So it still takes elements from. We can make this actually bigger, so it's easier to read. It still takes certain elements from mainframe, from the mainframe general approach, which is return codes. It uses very similar output from the normal assembler, and we'll look at that in a second to compare. So it says it's the same high-level assembler, and I guess to look at it properly, we just do it like this. Yeah, what did I say? ASA. We have to do it like this because I don't remember. EGMRSX YouTube, and I should be able to redirect the output into YouTube output. Assembler done, no statements flagged. I'm always surprised when things actually work. So let's go and look at this. Oh yeah, this is very, very similar. So at this point, I think I should make this smaller so we can compare it. Okay. Let's take any assembler output. Yeah, so this is from part 1, the last thing that I compiled in part 1, and look at this. Looks very, very similar. The zeros and the 3 here also actually exist in this output. It's just the SDSF removes it, but this is the line feeds for the printer. If I look at it without SDSF, we will see that it's still there. So let's look here. Here it tells me which PTFs are installed, where here I don't think we get this information. Oh yeah, it does tell me. I never looked at it before. So UK, this PTF is installed. The PTF, as you know, is a patch. So very similar. This looks like it's the same exact assembler, which is good. That's what you want. And then let's look at what it produces afterwards. External symbol dictionary. So this is very similar. And then we have the machine code generated. I have to make this bigger, or yeah, no, actually I don't. It's fine like this. So here we have the machine code generated. We see that register 12 is being used, and should be the same thing here. Yes, you can see that we have also register 12 here. And then let's go to the end of compilation. The cross-reference should also be here. In fact, I think I have the exact same code here. Yeah, this is the exact same code. So why don't we go back up here and look at the output. It should be exactly the same because it is the same program. So here you see we have 50D0 C04E, 50D0 C04E. Okay, here look at these 2 lines and at these 2 lines, and you see it's exactly the same, which is neat. So you can assemble from the command line, from the Unix command line, or from the shell, which is neat. Maybe even you don't have to do all the JCL stuff around it. For people who come from the Unix world, they can use this assembler within minutes. And this also looks exactly the same. If you look here, looks exactly the same. And then let's see, macro and copy code summary, exactly the same as in TSO. And then we have the diagnostic cross-reference. And of course here, now this is the interesting part, SYSIN here is this. Whereas here, of course, the SYSIN is the source code I just created, and the library here is the, I don't know what the CEE is, and here it's SYSMACLib, and modgen, and then syslibrary in. Sysprint is the disk, systerm is the terminal, and then we have here and this is the end here. So now let's see what it created. Linkage, how do I link? And link. What is the linkage editor? No. Linkage editor. How do I invoke the linkage editor? I don't really know. Yeah, we need the linkage editor. Maybe there's a way to have the assembler link at the end. No. Well, we can actually also use a PDS. This is interesting. So I don't really know how to link on Unix System Services. Let's see if there is a C compiler. Yeah, there's a CC compiler. So let's write hello. So let's see what comes out of this. How did I call it? The module CC on, well, there's something missing there, but could not compile. What is it saying here? To load the module into storage. So I don't know, but there is a CC compiler. Probably I'm doing something wrong. I mean, I don't know enough of this environment, but there's a C compiler which is also, I think, able to do C++. So other than that, I don't really know any other command. I mean, find probably works, yes. Is there an awk? Yes. There's an scd, yes. So this looks just like standard Unix. I mean, we don't have top, obviously, and stuff like that. Those are Linux commands, but it is quite similar to any other Unix. And so I think I'll stop my video here. So what we saw in this video is we can do structured programming in high-level assembler, which is one of the things I'm going to miss when I go back to my MBS 3.8. And we have the assembler also from the Unix command line on ZOS, which is neat, especially for people coming from the Unix world to the mainframe for the first time. And there's a C compiler And this is about all I can tell you. Hope this has been fun and interesting to you. And see you soon back on the MOSHIXX mainframe channel. Please consider subscribing to my channel so you get notifications of future videos. And if you like this particular video, I would like to invite you to press on the thumbs up button. And thank you very much. Goodbye.